Welcome all to today's lecture. Myself Assistant Professor Tukur Gupta from Ajay Kumar Garg Engineering College, Ghaziabad. The subject I am covering is microprocessor and microprocessor KEC 502, and this subject is being taught in 5th semester. The unit 1 we are covering, and the instruction set of 8085 is being covered in all the ongoing lectures. So in the previous lecture, I had already covered the arithmetic instruction set and the data movement instruction set, data transfer instruction set. So today, the next category that I am going to cover is logical instructions. So the basically these logical operations are covered under this category: AND, OR, XOR, rotate, compare and complement. So first of all we will cover AND, OR and XOR. So by default, one of the operand in all these instructions is accumulator. So the contents of register or memory location, they can be logically ANDed, ORed and XORed with the contents of accumulator, and the result is stored in accumulator. Let's see them one by one. So first instruction that is covered is ANA. Operands are register or the memory. So this is how this is performed. ANA B means the contents of B are logically ANDed with the contents of accumulator, and the result is stored in accumulator only. Similarly, ANA-M, it suggests that the memory location contents, which memory location? That is being pointed to by the contents of HL register pair. So this memory contents are logically ANDed with the contents of accumulator, and the result is stored in accumulator. Sign, 0 and parity, these flags are modified. Carry is reset and auxiliary carry is set. Next instruction is ANI, and this is the immediate addressing mode instruction. So obviously operand will be 8-bit data. So this 8-bit data is logically ANDed with the contents of accumulator, and the result is placed in accumulator. Sign, 0 and parity, these flags are modified to reflect the status according to the result. Carry is reset and auxiliary carry is set. So this is how the flags are modified according to this instruction. Example is ANI 86H. So this 86H is ANDed with the contents of accumulator, and the result is stored in accumulator only. So this is how this operation is performed. Next is OR. So the contents of register or the memory locations are logically ORed with the contents of accumulator. So, sign, 0 and parity flags are modified according to the result, similar to in the case of ANDing operation. Carry and auxiliary carry both are reset. Example is ORA B, that is the logically ORing the contents of register B with accumulator, and this instruction ORAM is logically ANDing the memory contents with the contents of accumulator, and the result is stored in accumulator. Next operation in this category is ORI, means the immediate data, 8-bit immediate data is logically ORed with the contents of accumulator. The result is stored in accumulator. Sign, 0 and parity are modified to reflect the result. Carry and auxiliary carry are reset. ORI 86H, that is the immediate data 86H is ORed, logically ORed with the contents of accumulator, and the result is stored in accumulator. Next instruction is XOR operation. XRA is the instruction. Operands are R and M. Similar to the previous two instructions, this instruction also XOR the contents of register or the memory location contents with the contents of accumulator, and the result is placed in the accumulator. Sign, 0 and parity. These three flags are modified according to the result of operation. Carry and auxiliary carry, both these flags are reset. XRA B and XRA M. These are the examples of this instruction. XRA B does what? It XORs the contents of register B with the contents of accumulator, and similarly this instruction XORs the contents of memory location pointed to by the HL register pair with the contents of accumulator, and in both these cases the result is stored in accumulator. Next instruction is the immediate addressing mode. Again XOR operation but with the immediate data. So the immediate 8-bit data is XORed with the contents of accumulator and the result is stored in accumulator. Sign, 0 and parity are modified. Carry and auxiliary carry are reset. XRI 86H is the example. It will XOR the immediate data, that is 86H, with the contents of accumulator. Next category is the rotate instructions. These are also categorized under the logical operations, and the purpose of these rotate instructions is to rotate the data left or right with or without the carry. So in this way 4 instructions are proposed. Each bit in the accumulator can be shifted either left or right to the next position as shown. So let's see the first instruction in this category, that is RLC, rotate accumulator left. Each binary bit of accumulator is rotated left by 1 position. Okay, so we have to, this instruction rotates the accumulator only by 1 bit. Bit D7 is placed in the position of D0 as well as in the position of carry flag. So as you can see that these bits are rotated left. Yes. So in this way, and this bit goes to, so MSB goes to LSB, that is the D0 position, as well as this bit goes to carry. Okay. And one thing to be noted is that the carry flag does not comes to D0. So this we have to keep it in mind. Carry is modified according to the bit D7. Sign, 0, parity, auxiliary carry. These are not affected. So this we should note that these flags are not affected, only carry flag is modified according to the D7 bit. Yes. So when this bit gets shifted to carry, so the carry flag gets modified according to this bit. Example is RLC. So no need to mention any operand, no operand is required here. Okay, writing just RLC, it shows that the rotate instruction is to be performed on accumulator. Next instruction in this category is RRC, rotate right, and by default the operand is accumulator, so no operand to be mentioned. So each binary bit of the accumulator is rotated right by 1 position. Bit D0 is placed in the position of D7 as well as in the carry flag. Means, so as we saw that this accumulator got shifted to the left, but in the case of RRC this will be shifted to the right in this way. Yes, and finally this D0 bit will go to the carry. Yes, so D0 bit will be placed in the position of D7 as well as in the carry flag. Carry is modified according to the bit D0. Sign, 0, parity and auxiliary carry are not affected. Example is RRC. Again, no need to mention any operand. By default, accumulator is the operand here. Next instruction in this category is RAL, that is the rotate left through carry. So the carry is also being rotated. Let's see how. So this is the rotate left instruction. So everything will be rotated towards the left. So each bit will get shifted to the left. And this bit will be going to carry flag and the carry flag will be shifted to the D0. So this is D0 and this is D7. So in this way, the rotation is being performed through the carry, including the carry also. So the carry is modified according to the D7 bit. Signs 0, parity and auxiliary carry are not affected. Example is RAL. Next instruction, RAR. Again, similar to RAL, the only difference is the direction of rotation. In the case of RAR, this direction will be modified as this. Yes, and again, this bit will go to the carry flag and carry flag will go to the D7 bit. So, D0 bit is placed in the carry flag and carry will be placed in the D7. So, carry is modified according to the bits D0. Sign 0, parity and auxiliary are not affected and the example is RAR. Next instruction is the compare instructions. So, any 8-bit data or the contents of register or the memory location can be compared for equality, greater than and less than. So, these are the 3 conditions of comparison. So, the instruction which is provided in 8085 is CMP. It will compare register or the memory location pointed to by the register pair HL register pair. It will compare the register and memory with the accumulator. So, by default, one operand is accumulator in this case. So, everything which is given in the accumulator is compared, in the operand is compared to the accumulator only. Both the contents are preserved. This we have to note that no changes are being made. Only this is suggested for comparison purposes. The result of the comparison is shown by setting the flags of PSW as follows. If the contents of accumulator is less than the operand content, that is the register or the memory, the carry flag is set. Because we can understand this by means that in the comparison operation, basically subtraction is performed. So, the contents of the operand, yes, operand is register or the memory. So, the contents of this operand is being subtracted from the contents of accumulator. Yes. So, if this contents is less than this, obviously the carry flag is set. And if the contents of accumulator is greater than the operands, the carry flag is not set. That is, the carry and the 0 flags are reset. And if this is equal, then these will be, the 0 flag will be set. So, this is how the comparison is performed. Example is CMP-B or CMP-M. So, according to this instruction, the contents of register B are compared with the contents of accumulator. And according to this instruction, contents of the memory location are compared with the contents of accumulator. Next, the immediate data is compared to accumulator, and the instruction is CPI. As this mode suggests, this is the immediate addressing mode, and the I denotes that this is immediate data. Again, 3 conditions. If accumulator is less than the data, carry flag is set. If accumulator is equal to data, 0 flag is set. If accumulator is greater than data, the carry and the 0 flags are reset. CPI 89H, this may be an example. In that case, the contents of the immediate data is subtracted from the contents of accumulator, and accordingly this result comes. Next instruction in this category is complement. So what is being complemented? Obviously accumulator is being complemented. The contents of accumulator are complemented. No need to mention the accumulator in the operand. This is self-understood and no flags are affected. This, what it will do? It will just complement the contents of accumulator. Suppose in the accumulator the data is 1 0 0 1 0 0 0 1. So now after performing this CMA, what will be the contents of accumulator? 0 1 1 0 1 1 1 0. So this is how this instruction modifies the contents of accumulator. Next instructions are related to the carry manipulations. Suppose we want to complement the carry flag. So CMC is the instruction for that. This instruction will complement the carry flag. If the carry is 1, this instruction will make it 0 and vice versa. Next instruction is the STC, that is the set carry flag. It will set the carry flag to 1 and no other flags are affected. So in both the instructions only carry flag is affected, no other flags are affected. So these were the instructions under the category logical instructions. So first of all we studied all these 3 logical operations. Then rotate instructions RAR, RAL, RRC and RLC. Then compare instructions and then the complement instructions. So this is how we complete the logical instruction category. That's all for the day. Thank you.